14.4. Solving trig equations. If y'all know what's going on already and I don't need to teach this section, then that's fine. I can go ahead and assign problems, but I'm not in for talking, okay? So, unless you're specifically asking me a question or answering one of my questions, there should not be talking going on. Okay, so this section is solving trig equations. Okay, so we have basically now the stuff that we've been doing, you have it equal to 0 and you have to solve for x. Okay, so this is going to throw back in inverse trig stuff that we've had. It's going to do solving just equations in general, so hopefully you remember how to do that. And then it's going to throw in one other thing that you should have seen before with a different topic called extraneous solutions. So really quick, we'll talk about that, and then I'll do we'll do a review of inverse trig, and then we'll do that. Okay, so with inverse trig, okay, where does sine occur?
On the right side.
Okay, yes, on the right side.
Oh.
Specifically from negative pi over 2 less than or equal to x less than or equal to pi over 2. How about arc cosine?
Top, right? Like on the
Yep, top.
correct. Like
So it is from 0 less than or equal to x less than or equal to pi. And then arctangent occurs where?
on the right.
Okay, on the right. From negative pi over 2 less than x less than pi over 2. Okay, so with extraneous solutions, basically these are solutions to the problem that aren't actually true. Okay, with these, it requires that we check the solutions back in the problem to verify that they work.
Did we get extraneous solutions or something else?
Yes, with inequalities. I think it was inequalities. Yeah, something like that.
Is that with event?
What?
Aren't that aren't actually true.
That was gonna be, sorry.
So they were just like when they give you a problem and it says like check to see if these are true. The ones that aren't true are extraneous solutions.
Yes, but no. That's not, like, basically when you solve an equation, like, I'm just going to use like x squared plus 4x plus 2 or whatever, okay? Whenever you go through and you solve that, that's not even something you could do, just factoring. But anyways, you get different, like, you get a couple answers for that. Basically with this, it would be that one of them is not true. Like, it'll look like it's true when you solve it, but when you plug it back in, it actually won't make a true statement. Everybody have this? I just want to make sure we had it before we start examples. All right.
Wait, already?
Yep.
That's all?
Yep.
Wow. Do I need a calculator?
No,
Awesome.
you do not. All right, so we're going to verify that the x value is a solution of the equation, okay? So in these ones, basically this is the checking portion, okay? So these ones purely are telling you, take the value for x and plug it in and tell us if the statement is true or not, okay? So this problem is pi times the secant of x plus pi is equal to 0, and it tells us that x is equal to pi. All right, so with these ones, like I said, I'm purely just plugging in. Okay, so I am putting in pay attention, please. I'm putting in pi for x, so pi times the secant of, okay, I'm putting in pi, plus pi is equal to 0. Okay, what would the secant of pi be? Okay, think about cosine of pi. What is the cosine of pi?
2.
Well, it's 1 with a something on it.
Oh, wait.
-1, okay.
Yep.
So just so we can see how we're thinking about this, okay, I'm thinking about this as 1 over the cosine of pi. Okay, so cosine of pi is -1, so this is going to be negative pi plus pi is equal to 0. 0 equals 0, and we're done. Okay, so if, let's say we had worked this problem and we got out that x is equal to pi. Okay, that's what we would have gotten out of the problem. Basically, they've already done all that. They're giving us the answer. So we're checking to see if it's extraneous or not, because we're taking that and plugging it back in to see if it works. Okay, so we're doing like the second half of what your problems will look like first. Yes, Berkeley.
So, say for the problem, you're using pi. So if it was like 2 pi, it's like you're using a pi circle.
Yes. And I think for the most part, they're going to give you values that you should know off the unit circle. And I think for the most part, your answer should be something that comes off of it.
So if it was not equal to 0, it would not be an extraneous solution.
Correct.
Okay, so you can just put a check in that equals extraneous solution. You can just know that.
Okay, if you, for the test or like any of the quizzes, do we have to know the unit circle or are you giving it to us?
For chapter 14, you will get a copy of it. So just remind me, I have classroom ones here.
Where did the negative pi come from again?
Because the cosine of pi is -1 from the left side of the unit circle.
That's right. Okay.
Never mind.
Was that your question too?
Well, I was like, where did the, why, yeah, I was like, why did that one just all of a sudden become negative pi, and where did the -1 go? And I multiplied.
Yeah, basically I just kind of skipped the step here that this is pi times -1. Okay, if you need to write out all the steps, you can absolutely do that. Okay, I just skipped some of those kind of steps just to save room, and not that I have, you know, not infinite space on here, but when I tried to save the trees more, you know. Not really. I don't care that much. I mean, I like trees, but not that much. I don't care about them that much. All right. I'm gonna do 8 because 8's a little bit more involved here. 3 cotangent to the 4th of x minus cotangent squared of x minus 24 is equal to 0, and we're told that x is equal to 7 pi over 6. Okay, so I'm gonna give everybody a second to get this written down first. Okay, same instructions from 4. and also in case you've been wondering why you haven't had like videos to watch at home, I just think Trig is kind of easier just to do in class. That if there's questions, that's why.
I was literally
So-
just thinking that right when you said that. And I was like,
Yeah, there might be some sections where like I don't know, there might be one or two sections here still in chapter 14 that you might get a little video for just to save some class time, but we're okay on time with like where we're at in the book, so
Are we going by slower or faster than for the
slower than we really should be, but that's fine.
So how many more chapters are there?
Well, we have to get to chapter 14 and then we're going to have bits and pieces of 6 and 7, I think.
Wait, so is the reason we're behind because there's 2 weeks of quarantine?
No, we're just, I don't know, we're just behind. I don't really know why.
we also took our time on
Yeah.
this. He gave us extra.
Yeah, I don't really know what happened. I don't know if last year was just super fast or if I'm like actually
Well,
behind.
also, they're really smart. Agreed.
Yeah, they had a much more like math thinking brain.
All right.
I can do patterns.
So I'm going to plug in 7 pi over 6 anywhere I see x. So 3 cotangent to the 4th of 7 pi over 6 minus cotangent squared of 7 pi over 6 minus 24 is equal to 0. Okay, things to keep in mind here. Okay, the way this is written, this is the same thing as the cotangent of 7 pi over 6, the whole thing raised to the 4th. So that's how you're really going to want to think about this when you're doing this. Okay, and then the cotangent of 7 pi over 6.
Like when we do our homework, can we write like what you're writing in green? Can you just write it like that? Because otherwise, I'm gonna forget.
Yeah, that's fine. That's why I'm trying to show you like the step that it's easier to think about it that way, but you don't necessarily have to write it that way. I'm fine with you doing it either way. Okay, so obviously cotangent is not something we know off the top of our head. Okay, but we do know tangent, or we should. I'll grab a unit circle just because I don't know if y'all remember it off the top of your head.
Well, it's
I know
7
7
pi
pi.
over 6, so it's like.
Okay, so, well, here. So the tangent of, where's 7 pi over 6? Down here. So tangent of 7 pi over 6 is root 3 over 3. Okay, but remember, okay, yes, because when we have, these are the tangent values here, but when I switch to cotangent, these values flip, so it's just going to be root 3. Okay?
Only with cotangent. Other than that matter with like secant.
Correct, just, just tangent and cotangent. Okay, and it's the pi over 6s and the pi over 3s. The pi over 4s are always just 1 or negative 1. Okay, so we're going to have 3 times, okay, the cotangent of 7 pi over 6. Okay, we said that's root 3, but remember the first time we're going to raise it to the 4th, minus, and then in parentheses, root 3, and that's going to be squared, minus 24 is equal to 0.
Where'd the oh never mind.
Wouldn't it, so when you're solving these problems, you do exponents first? No. You do exponents first, yeah.
Well, parentheses, then exponents.
Yeah, so since you're doing it to the 4th power, would it just be 3 times 3?
Yeah, because the square root of 3 times the square root of 3 is going to just be 3, and then I've got basically 2 of those. So 3 times 3, so it's going to be 3 times 9. Okay, this 3 is outside. Okay, if you want to do this all as one step, that's fine. I'm just going to break it up just so we see what's happening as we go right now. Minus, okay, the square root of 3 times square root of 3, we said is 3. Minus 24 is equal to 0. So this is 27 minus, that's going to be 27 there, is equal to 0. 0 equals 0, so that one worked.
Okay, that
Okay,
makes
where the
sense.
heck did you get the 9 and then the 3 from?
Square root of 3 times the square root of 3 is 3. And then I have another square root of 3 times square root of 3 because it's raised to the 4th. So that's going to give me 3 times 3.
Oh!
Okay.
Right! Because it's just like, the square root is just like, I get it.
Okay, so let's have you try one of these. Okay, there's not a whole lot of this type because then the rest of them are actually solving them. So that's why I'm going to go ahead and have you try one of these to make sure that we understand how to plug it back in so that once we solve it, we know how to go back and check them. So you're going to do number 6. 5 tangent cubed of x minus 5 equals 0. And x is equal to pi over 4. And everybody is doing this as participation grade.
Are you gonna do that whole thing where you come? I mean, I'm gonna do it either way. I'm just asking because, like, are you gonna come around and check it? You know how sometimes you do that.
I might,
Okay, I was just curious.
because we've got a sleeper.
Oh,
That's why I'm grading it. Don't fall asleep in my class.
I like the fives.
Thought you might.
5's plural? Oh. There's another 5.
I have a question.
Yes.
So we started with cotangent in the last one.
Mhm.
We used the root 3 over 3 for tangent. So we just start with root 3 over 3 for that.
Well, so it's going to be whatever the tangent of pi over 4 is what you're using.
Oh, I
Are we gonna have a unit?
Sarah, can you put the units
Yeah.
for class real quick?
Ooh, can you? One.
figured
Okay.
it is
Where?
One.
Wait, this is, thank you.
I'm just going to wait and write that down.
I like this a lot better than what we did last time. It was so, like, a lot.
Oh, I like this.
We've gotten to where they're giving us the answer. We still have to do the ones where we find the answer.
I'm so smart.
But they're actually really not that bad. As long as you remember your inverse trig rules, you will be fine.
I just really don't, like, my brain has a hard time
I
understanding
know
the
what
last
I'm
chapter.
doing.
I know, I like was looking at the thing and I was like, I know which one to go right.
We should do another one by ourselves.
Are you graded so
Oh,
you
I
get this
did that
right or not?
No, I'm just making sure you're attempting
I
it.
don't think I'm gonna get it right.
It's like, oh, this is.
1 times 1 times 1.
Yeah, I figured it out.
When the dots finally connect.
Luckily it was 1 because I literally just forgot the cube in the entire problem.
I need my goldfish too fast. And now I'm sorry. I finished.
She had a nerf gun and just like, okay. Sine cube minus
That's what Mr. Haggerty had.
All right.
Oh.
My teacher would just come around and slap you on the back of the head with a ruler.
I'm gonna take a picture, just so
So that the grade is explained. But I do have proof.
We have to have video and everything.
All right, let's see. So I'm guessing it worked.
Yes. Sorry.
It did.
Okay, so I'm plugging it in. 5 times the tangent of pi over 4 cubed minus 5 equals 0. The tangent of pi over 4 was 1. 5 times 1 minus 5 equals 0. 0 equals 0.
Woo, dang.
Done.
I had like double the amount of steps as you, just so I could show all my work possible. And I was like, how did I have 6 lines and you have 3? But because I know what I'm doing, and let me just tell y'all that means that that means the world ending really. So it doesn't matter how easy it is. I can't even add.
All right, the next one say to find the general solution.
That sounds
Wait, so is there a specific?
Okay, let me, hold on a second. We need to go back, like take a step back before we do that because I forgot that was part of this section. Okay. Okay, so when it asks for a specific solution, that's when we're getting something like x is equal to pi over 4. Okay, the general solution means it wants all possible solutions.
How can there be more than one solution to a problem? But never mind.
Okay, so that means that we need to keep adding, basically adding 1 every time. Okay, to get our value. So with a general, we are going to add 2 in pi to include all possible solutions because in technicality there are infinitely
Of course.
many solutions.
As there should.
Okay, so do this when it asks for the general solution. Okay, so that's what your instructions are going to say, is to give the general solution. And so when it says that, you need to add 2 n pi.
What does the N stand for?
The number of times it goes around. Now, the exception
No.
is with tangent, okay, because of the way the values repeat. Okay, we only need to add n pi instead of 2 n pi. Okay, so this is for sine and cosine. Okay, for tangent, we're just going to add n pi. Okay, because on the unit circle, okay, I'll put that back up in just a second. But the unit circle, okay, the tangent value up here is equal to the tangent value down here. So I only need to go around 1/2 time, basically, to get the next tangent value that's equal to it. And then I can go around again. But in order to get back to the cosine being root 3 over 3, I've got to go around a whole time because there's nowhere else that the tangent is equal to root 3 over 2. Okay, that's not negative. Okay, or I mean cosine, whatever. Okay.
I don't really understand what she just said, but I only need to know is that you can't use tangent for this or whatever, and it's fine. I'll just read the note and
Yeah, I more so just was like giving a quick little visual for visual people, but yes, you really just need to know that it's add 2 n pi for sine and cosine, add n pi for tangent.
yes, that's all I care. Yeah.
Because, okay, I guess in technicality, no, I'm just going to explain something to make sure that we're not confused if you're sitting here questioning what I just said. Cosine technically occurs at root 3 over 2, which is at pi over 6, and at 11 pi over 6. But there is no easy way for me to add to get from pi over 6 to 11 pi over 6 that's consistent for every single thing. Okay? So it's easier just to say add 2 n pi. It's not necessarily wrong for tangent to do that, but tangent you don't need to do that. You just need to have n pi.
Are there cotangents you get in cosecant?
I think the only ones that they have you do are sine, cosine, and tangent. But it would be the same. Like cosecant and secant would go with the sine and cosine ones. But I'm pretty sure the ones I'm giving you are only sine, cosine, tangent. Okay. So, okay, again, so these say find the general solution. Okay, so number 10 is the square root of 3 cosecant of x plus 2 is equal to 0. Okay, I just lied. This literally, the first one is cosecant.
Oh.
But we're going to treat it as, okay, we're going to treat it as sine though, so it'll be fine.
So you don't use the 1 over.
Well, yes, we are, because we're going to treat it as sine.
So we're gonna pretend it's sine.
Yes, we're going to rewrite it as sine in just a minute. Not yet, but we will.
I hate this.
Okay, so I need to solve for x. So the first thing I need to do is subtract over the 2. So square root of 3 cosecant of x is equal to negative 2. Now I'm going to divide by the square root of 3. So the cosecant of x is equal to negative 2 over the square root of 3.
Wait, don't you have to simplify it?
Nope, leave it for now.
Ooh, nice. Oh.
Okay, now I'm going to show you something, and I need you to pay attention closely so that we don't get confused, because I know somebody's going to end up confused. Okay, cosecant can be written as 1 over sine. Okay, that's one of our identities. 1 over sine of x is equal to negative 2 over the square root of 3. Okay, but I can't get x by itself right now because of where it is. But because I have fractions on both sides, I can flip both of them. Okay, so it's going to now be the sine of x, and I'm just going to put the over 1 just for the moment so we see what's happening, is equal to the square root of 3 over negative 2. Okay, do we see what just happened?
Yes.
Okay, it completely, both sides had to do it at the same time, and they both flipped. because I need to have x on top.
Okay.
Okay? Now, okay, I don't need this one on the bottom. I'm going to get rid of it because it annoys me when people put ones on the bottom. Anyways, okay. Now, what do I need to do to get x by itself?
Divide by sign, right?
What do you mean divide by sign?
Inverse sign.
Inverse sign.
sign.
Okay.
Never mind.
That's what I was thinking. You probably meant that. That's why I was trying to make sure. Okay, so I'm going to take the inverse. So x is equal to sine to the negative 1 of negative root 3 over 2. So remember, we talked about earlier, okay, sine occurs on the right-hand side. So I need, and remember, it's negative pi over 2 to pi over 2. Okay? So I need to know where is sine equal to negative root 3 over 2. Okay, so sine values are y values. I need negative root 3 over 2. Okay, which is 5 pi over 3. Okay, let me see which way the book is writing them just to make sure that they're actually going to do it correctly. Where are these answers? Over here somewhere.
Negative pi over 3. In reality.
It would be negative pi over 3, right? Yeah.
And just their answer is saying that it's something completely different. So that's why I'm just trying to look. Oh, okay.
I don't like this.
There we go. Okay, yes. 5. Okay. They actually don't actually follow the negative pi over 2 to pi over 2 in the book. Okay, so you can ignore that part now. Apparently that's
Yay!
irrelevant now according to our book. So we're going to ignore that. Okay? So it's just going to be 5 pi over 3. Okay, that's where it occurs.
What are you talking about?
Okay, so when we have inverse trig, we can only be on the right-hand side for sine. And it says that it's supposed to be from negative pi over 2 to pi over 2. Meaning that this should really be negative pi over 3. Okay, you follow that? Okay. However, the book is telling me that that is not what they want, and they want the 5 pi over 3 value that's actually on the unit circle.
Sweet. Well,
So just use those values.
So we don't. The thing you talked about in the beginning with the green thing doesn't matter. Like the 2 and pi, or is that we're not?
No, we're still, that's what I'm getting ready to tack that part on.
How did we get the negative 1 exponent besides sign?
Because to get x by itself, we had to take the inverse of it to get rid of it.
Oh, so when we flipped it? Okay.
So then over here, we need the general, so this is going to be plus 2n pi. Okay, and with these ones, you don't need to check them because they're general solutions.
That's the answer.
Oh. The heck? I thought this was gonna be so much more complicated. I'm not complaining, I'm glad it's not.
Are we gonna have to do more with that later?
Yeah. I just
Yes, because in technicality, we're not done yet. There's one more answer here.
Is it the? I don't know.
Okay, so we obviously did our review of inverse trig, but now apparently they don't care that we follow the inverse trig rules. Okay, so where else does sine equal negative root 3 over 2? Okay, at 4 pi over 3. So another option, okay, and you technically need to have both, is going to be 4 pi over 3 plus 2n pi.
So we're not following the inverse trig function.
Apparently they don't want us
So
to
it
do that
teaches
anymore.
to it,
So
but
what is
they
the
don't
point
teach
of
it.
calling
I think they want that when they want an exact value, as I think what, like when we're just wanting the exact solution, like with what we did. Anyways, now you can apparently ignore that because they just don't care anymore.
I hate that.
Hey, you
It
know
really doesn't make sense, but we're going to do it the way the book does it because that way you're not confused when you're checking your answers, and
Yeah.
it just makes our life a little easier because you don't have to remember to make it negative and all that fun stuff.
Now I have to worry about.
I'm just using this where you got the 5 pi and the 4 pi.
From the unit circle where sine is equal to negative root 3 over 2.
Mine is X.
Sine's y.
Like Y.
But like, I don't see, I see the negative root 3 over 2, but not the 5 side. Oh, okay, I see.
So we're looking for the angle values when we do that.
Okay.
All right. Let's do another one.
That took up almost the whole page. I know.
Really? She just writes excessively.
No, you just write really slow.
I write in the
Berkeley?
line.
Berkeley,
It didn't even take up half of
that.
No, but I use this side too.
I think I just wrote like my version.
All right, so now I have sine of x plus the square root of 2 is equal to negative sine of x. Okay.
Step,
Good back jump.
Moving it over to the left
so you
side.
add it to the other side and then you get 2 side. No, you get 0. So
You subtract sine of x, right?
no, right.
You
To move it from one side to the other, I've got to change the sign.
Fine.
The
Plus-
sign of sine.
Plus.
Can we just
that
do?
is
Can we do
equal
both
0.
at the same?
Yes, you can. That's what I was going to do. But then I was being yelled at to write plus the square root of 2, so I just wrote it.
Oh, never mind.
Why can't you write plus the square root?
Because you can also just.
Because I could have just done it all in one step and saved a line.
No,
Berkeley.
I just.
you have to write
I
every
think
single
she's talking
thing.
about me, but I don't understand what you're talking about.
I could have just, in this step, I could have moved this over
Oh,
and
I didn't
moved that
realize you were
over.
even supposed to move to the other side. I just thought it was going on the same side. That's why I was saying it.
But
No,
it's
you're
not-
good. I was just
Oh,
joking with
I
you.
thought 0. I thought we were supposed to make them equal to 0.
Now you divide by 2, right?
No, because I want to get x by itself.
I just don't get
I did not understand the goal.
Can you divide by 2 or do you have to
Yes.
divide?
Divide by 2, so sine of x is equal to negative root 2 over 2. And ignoring our rules of inverse trig, where's the sine of x equal to square root?
Negative
7
1.
pi. Wait. Yeah, 7 pi.
Just gonna, real quick. Am I allowed to put the unit circle up here?
No, do it.
Okay, I just thought I was gonna get yelled at again.
No.
Where is sine equal to negative root 2 over 2?
Pi over 4 and 5 pi over 4.
5 pi over 4 and 7 pi over 4. So x is equal to 5 pi over 4. X is equal to 7 pi over 4. I'm dealing with sine, so I'm going to add what?
2 and pi.
2 and pi.
This is so much easier than I thought it was.
I hate it.
Again, she's not complaining.
It's actually not as hard
This
as
is.
I feel like this is not
We
normal.
know to divide by 2.
Because I need to get x by itself, so I'm doing piece by piece what I need to do to get x by itself. Alright, it is your turn to try one.
I'm excited.
Okay, this one is going to be tangent, so when you're done, add n pi, take your hood off. Add n pi, not 2 n pi.
Got it.
Okay?
Wait, can you say that one more time?
This one's going to be a tangent problem, so when you get to the end, add n pi instead of 2 n pi.
Thank you. I heard you say it and it
It registered, but like did it completely
3 tangent squared of x minus 9 is equal to 0. Okay? Just really quick before you do this. Okay, when you have this, okay, again, treat it as the tangent of x and then the whole thing squared. So take the square root before you try to inverse it.
Got it.
Okay? But you got to do stuff before you do that.
What's wait, are we doing?
Yes, this one you're doing by yourself.
Oh, sorry.
Do it by
What was the
myself.
number for the last one we did?
Huh?
Like,
12.
So you said take the square root before we inverse it, correct?
Yes, but there's things that have to be done before you can even do that.
To get rid of the square, you just
Take square root. Can you put the unit circle like up on the board?
Yeah, does everybody have the problem written down?
I don't even know what we're doing.
Please just.
Alright. Well, you should have it written down by now, so there you go.
No, wait. Can we try it on our own first? We are.
Yes, I'm just putting the unit circle up as I was asked to do.
So we're not following the rules, so we just write.
So do it for just both values that are equal to that.
This would be really good if I could.
you're just adding n's pi.
Something is not looking right over here, guys.
Awesome.
You got it? Let me see.
Show it to you.
No, not the last one, hon.
That's what I got.
Hi.
I tried, but
Was that your tangent square?
I got it. I promise. I'm not
That's
Oh,
minus
well,
nine.
maybe you're right.
Yeah.
Maybe you're right.
Take the square root
I think
first.
Oh, yeah.
Divide by 3. Yeah. So it's 3, and then you take the square root of this.
That would make sense.
Oh, I forgot to take the square root of it.
Stop that.
This Earhart, no wonder I forgot to take the square root of it.
Fine, the square root is
God, I think I needed it over
Math.
Okay, what is that?
Is that
Pi 4 pi over 3. I have one in my car, maybe.
I have one in my car too, but I don't want to go all the way over.
Miss Earhart, have you
Then add
met
pi.
the new music teacher yet?
No.
Like by passing
4
through the
pi
hall?
over 3.
Hello?
Look at this. 4 pi over 3. Now what do you
Yes,
say about
it's
tangents? You just add what?
Who is?
I'm borrowing it.
All right, let's go over it.
I stole this.
All right, what do I need to do first?
You need to move the 9 over. Add 9 to both sides.
I don't like that Ariel knows what we're doing and I don't. It can do that.
And then
Divide
you're
by
gonna
3.
divide by 3.
Here, let Ariel do it.
And
Yeah,
then
Ariel's happy.
you're going to take the square root of both sides. And then that gives you tangent of x equals the square root of 3. And then on your unit circle, the
Thank you.
square root of 3 is equal to 4 pi over 3. Not equal to. Is that the right word? Yeah.
I'm so proud of you, Ariel.
What did you say it was?
4 pi over 3. So you have 4 pi over 3 plus n pi. And pi over 3 plus n pi, because that's the other side.
Little Ariel's growing up.
I really
You
am
can't
now.
really.
I don't know what we're doing.
Edit it
Squared is
together.
equal to 4.
So you have to take the square root of 4 to get to equal to x.
When I take the square root of something, what do I do?
You divide it by. I don't know.
I don't even know.
Square it to both sides.
When I take the square root of something, how many answers do I have?
2!
2.
Because positive and negative.
What?
Oh yeah.
No!
Oh my goodness.
So there's 4 answers, technically.
Yes and no. Okay? So technically, the stuff that she has is fine. We just need to add on the ones for negative root 3. However, because we just need to add n pi to them, in technicality, all I really need... Now, if you do it the way she did it, I will not take points off, okay, unless you just forget the negative root 3 one. But this is the only one you need for the positive one because we're adding n pi. So technically, this and this, they're equal.
Okay. I have a question.
What's equal to what again?
Okay, because with tangent, because of how their values are on the unit circle, right? Okay, they're complete opposites. If I just add the n pi, it comes back around and down here. So as soon as I add pi to pi over 3, I get 4 pi over 3.
Which means on the other one, that's not the negative one, so you have to have at least another
Correct.
one.
So I need to do the negative one. So where is x, or where is the tangent of x negative root 3?
5 pi over 3. And, yeah.
Okay, so 2 pi over 3. And what did we say? 5 pi over 3? Is that what y'all said? Okay, so these are the other two. Okay, I technically only need this one.
Why?
Because it's here and here. I add n pi and it gives me here. I add n pi to this one and it gets me back up here. Okay, cosine and sine, that's why we have to write all the possible options. Now, again, if you do it this way, like Ariel did it, okay, obviously adding on the negative ones, okay, I will not take off points for it. Okay, but in technicality, the only ones I need are 2 pi over 3 plus n pi and pi over 3 plus n
Could
pi.
you have the 5 pi over 3 one too? Like, instead of using 2 pi over 3, could you use 5 pi over 3 and not the other
You
one?
need to use the smallest one.
Okay.
So you have to use the pi over 3 and the 2 pi over 3 because they're the smallest ones. Okay, but if you write the other ones, I won't take off for it. Okay, just to make our lives easier, but you only need those two. Yes.
So I got confused on the 3 steps where we did 3 tangent squared x is 9. Then we took 3 off, tangent squared x is 3, and then tangent x is root 3. Like, how did we get different?
Well, from here to here, we divided by 3
Okay.
on both sides. And then we took the square root, which gives us tangent on this side, square root of 3 over here. And then I want to know, when I take the square root of something, I have to do plus or minus.
Right.
So I should have had the square root of 3 and negative square root of 3. This is one we just had to add on.
So technically, with the x equals tangent to the negative first power, you had 1 over tangent and flipped it. Right?
Kind of.
Okay.
We're
I'm just
technically
trying to, like,
still with
figure it all
inverse
out.
trig. Yeah, no, you're good. We're just technically doing inverse trig there. Just
Okay.
the modified inverse trig.
Find a human.
Okay? There's a lot of other talking and laughing going on that I'm pretty sure is not math, so I hope you understand because I'm not re-explaining that. Alright, your problems that go with this, okay, and then we'll add on the rest tomorrow. You need to do 3, 7, 11, and 13.
Single five.
Oh my gosh, but I stopped.